Hello everyone, welcome to ThinkComputer YouTube channel. In this video, I will explain what is a truth table, why do we need a truth table and how to draw a truth table. So a truth table in Boolean algebra is a tabular representation that shows all the possible combinations of inputs and their corresponding outputs for a logical expression. It helps us to determine the truth value of the expression under different input scenarios. Each row in the table represents a unique combination of input values and the columns represents the inputs and output. So for drawing any truth table, the basic rule that we follow is 2 to the power n formula. Okay, here n means number of variables. So basically we are making this table for Boolean expressions. Okay, and in Boolean expressions the value for any variable, Boolean variable, can be true or false. So true means 1 and false means 0. So the value can be 0 or 1. That is the reason why it is 2 to the power n, because 2 is the base for binary numbers. Okay, so we'll take an example. Suppose that we have got an expression x dash plus y. This is a Boolean expression. Okay, so for this expression we need to make a truth table. Well, first thing we have to do is we have to see how many variables are there. In this there are 2 variables, that means it will automatically be 2 to the power 2, which is equal to 4. So here 2 is the power value which represents n, means number of variables. So that means there will be 4 combinations in the table. Okay, so we'll draw the columns. First we will draw a column for x, then we'll draw a column for y, then for x dash, and then for x dash plus y. Okay, so first column will be x, which is the base column, then y, which is also base column, then for x dash, then for x dash plus y. Okay, now in the first column, that is the x column, I have to get 4 combinations, but since it is binary, so it can only be 0 or 1, correct? So what we will do is we will put 2 times 0 and we'll put 2 times 1. Okay, that will make it equal number of zeros and ones. Now in the next column we'll divide it by half, means after 1 bit only we'll change it, 0 1 0 1. Okay, so that is how we'll make it. We could have also done in the x column first 1 1 0 0, but then in the y column we had to do 1 0 1 0. That means if we choose to start with 1 in the first column, so in the second column we also have to start with 1. We cannot start in the first column with 1 1 0 0 and in the next column with 0 1 0 1. That will make wrong combinations. Okay, so that is how we will start with the base column. Now this is x naught, the rule of naught is applicable, which means 0 will become 1 and 1 will become 0. So here x naught will be 1 1 0 0. Okay, then x naught plus y, that is the x column, plus means the disjunction, I mean OR operation is happening. So in the x dash column and in the y column, if any 1 is there, then the answer will be 1. Only when 2 zeros are there, then the answer will be 0. We can also make the table using true and false instead of zeros and ones. Meaning will be same. Suppose I am making with true false, then I will write like this: x y x dash plus y. There are 4 columns. Okay, so first base column, second base column, then for x dash and for x dash plus y. If I am using true and false, then x column I am writing first false false and then true true. Y column I am writing first false, then true, then false and then true. X dash will be the not of x column, that will make it true true, false false, and x dash plus y, that is the OR operation happening, will make it true true, false and true. That means you can make the truth table using zeros and ones, or you can make the truth table using trues and false. That is your choice. Now let us see how to make a truth table for 3 variables. Okay, so if we have 3 variables, that means 2 to the power 3. So there will be 8 combinations. Okay, let me show you the combinations how to make. So suppose we have an expression x dot y dot z for which we are making a table. Now you can see there are total 3 variables. Okay, so obviously 8 combinations. So this is x column, this is y column, and this is z column. Okay, so x we are writing here, y and z. Okay, in the first column, equal number of zeros and ones you have to put, and there are total 8 combinations you need to create. So what we will do, we'll put 4 times zeros, okay, and then we'll put 4 times ones. Why? To keep the number of zeros and ones same. In the next column, that is y column, we'll put 2 zeros and then 2 ones and then 2 zeros and then 2 ones. And in the last column, that is z, we'll make 0, 1, 0, 1, 0, 1, 0, 1. In case if you are thinking why we follow this order, basically this predefined ordering of plotting values creates unique combinations. If you see any one particular row in this table, you will see that each row is unique. That means with 3 variables, total 8 unique combinations can be formed if we follow this particular order. And then we will have the column for x dot y dot z, okay, which is that if any 1 0 is there, answer will be 0, rest all 3 are 1, the answer will be 1 in that particular row. So this is what we are getting after following that. Okay, so this is a truth table for 3 variables. In case we have 4 variables, then it will be 16 combinations, that is 2 to the power 4. And in the first column, then there will be 8 zeros and 8 ones. And the column next to it will be 4 times zeros, 4 times ones, and 4 times zeros, and 4 times ones, and so on. I hope you have understood how to make a truth table for any Boolean expression. Thank you everyone for watching this video.